Welcome to the background video for SOL 6.12.
Teachers are encouraged to review the Strand introduction for the big picture of the standards. This is the introduction for the strand in which 6.12 falls, which in the 6th grade curriculum framework is on page 26.
The mathematical process goals that will be highlighted in this video include problem solving, communication, reasoning, connections, and representations.
6.12a and the corresponding essential knowledge and skills bullets represent a proportional relationship between two quantities, including those that arise from practical situations. The essential knowledge and skills ask students to make a table given a ratio or practical situation.
6.12b asks students to determine the unit rate of a proportional relationship and use it to find a missing value. The essential knowledge and skills bullets require students to identify a positive unit rate and find missing values in tables.
6.12c requires students to determine if a proportional relationship exists. The essential knowledge and skills ask students to determine from a table, verbal description, or graph of ordered pairs if a proportional relationship exists. Students will use the mathematical process goal of mathematical reasoning to determine if a proportional relationship exists.
6.12d and the essential knowledge and skills ask students to make connections of a proportional relationship with verbal descriptions, ratio tables, and graphs. What follows are slides from the Understanding the Standard, or left side of the curriculum framework. This is intended to provide information that teachers must know in order to teach the standard.
A ratio is just a comparison. It can be written with a colon or as a fraction. Students need to understand the order of the numbers refers to the order of the comparison. The comparison is the number of dogs to the number of animals. Students cannot write 9 to 3 because it is not in the order of the comparison.
Mathematical connections can be made between what students already know about equivalent fractions becoming equivalent ratios. Students can say that for every 6 dogs, there are 18 animals as they multiply the fraction by 2 over 2. Or that for every 1 dog, there are 3 animals, as they divide the fraction by 3 over 3.
Continuing with this example, another representation is a table. In this table, we see that multiplying the number of dogs by 3 will always result in the number of animals. The 3 is the constant of proportionality. Multiply the first quantity, dogs, by 3, and this gives the second quantity, animals. Students need to clearly understand that the constant of proportionality is what we do to one quantity to create the other quantity.
In the additive relationship, y is the result of adding 8 to x. In the multiplicative relationship, y is the result of multiplying 5 times x. The ordered pair 2, 10 is a quantity in both relationships. However, the relationship evident between the other quantities in the table discerns between additive and multiplicative. Teachers should assist students in making the mathematical connection to their experiences with tables of values, input and output tables that are additive and multiplicative, in elementary grades.
A proportion is two equal ratios. Proportions can be used to show a proportional relationship. Here we can see the proportional relationship between 1 and 3 and 4 and 12. Teachers help students make the connection to the constant of proportionality as the constant that can be multiplied by the measure of one quantity to get the measure of the other quantity for every ratio pair. A possible misconception that might affect student learning is that the constant of proportionality is not the same as the number multiplied by the numerator and denominator to make equal fractions. Here we see, to show equivalent fractions, we multiply both the numerator and denominator by 4, but the relationship between the number of dogs and the number of animals is the constant of proportionality, or 3.
Students need to be able to find and use a constant of proportionality to find other values in creating a ratio table. Notice on the ratio that is given, in y to x form, the first number of the ratio goes in the y column in the table, and the second number goes in the x column. Teachers need to help students recognize that even though the ratio is y to x, we still need to see what to do to x to make it into y. Teachers should help students make connections with their prior knowledge of input-output tables from elementary school.
Unit rate is not a tricky concept, just a big name for a rate with a denominator of 1. Students just need to know that a unit rate is determining how many of the first quantity corresponds to 1 unit of the second quantity. Here we've shown how to go from the given ratio to the unit rate by dividing by 5 in the numerator and denominator. This will be shown in fractional form on the next slide. Unit rate is important because in 7th grade, students will learn that the unit rate may represent the slope of a proportional relationship.
Here you can see the same concept. With the fraction being 8/16, both the numerator and denominator are divided by the denominator of 16, resulting in 5/10 as the numerator and 1 in the denominator. Teachers need to help students make the mathematical connection with the real-life examples that we inserted here, where using unit rate or unit price helps shoppers determine the best deal.
Teachers should be careful not to teach the slope formula. Rather, students should determine slope using proportional reasoning in table form and constant of proportionality and unit rate.
This bullet in the Understanding the Standard gives an example of using proportional reasoning, using unit rate, finding values in a table, and real-world examples. Since the ratios are equivalent, this is an example of proportional reasoning.
Here we see an example of non-proportional reasoning. In 6.12c, students are to determine whether a proportional relationship exists between two quantities. Therefore, students will need to see examples of proportional relationships and examples of non-proportional relationships.
It is noted in the Understanding the Standard that these verbal phrases indicate proportional reasoning, and teachers can help students make the connection to unit rate because we are finding the rate for 1. Teachers need to be wary of teaching key words, and instead encourage students to use the unit rate language by saying, for every. In this example, it would be 6 miles for every day. For each, in this example, it would be 6 miles for each day. Or per, in this example, it would be 6 miles per day, when you're describing a context. Teachers should help students understand that the statement 6 miles for every day means 6 miles for every 1 day. 6 miles for each day means 6 miles for each 1 day. 6 miles per day means 6 miles per 1 day. This will help reinforce the meaning of unit rate.
Teachers help students see multiple representations for proportional relationships by showing verbal descriptions, tables, and graphs on the coordinate plane with ordered pairs from the table. Note that the linear relationship is 1 liter of syrup to 3 liters of water, which leads to the ordered pair 1, 3, since x represents syrup and y represents water.
Here the ratio has changed, such that x now represents water and y represents syrup. Therefore, the relationship becomes 3 liters of water to 1 liter of syrup, making the ordered pair 3, 1. Defining your variable becomes important for mathematical communication. In 8th grade, students will be expected to determine the independent and dependent variables to define the variables y and x respectively.
Here is yet another representation for the same example of water and syrup. The proportional relationship is shown with 2 number lines where the relationship is still 1 liter of syrup to 3 liters of water. This visual may help students make the connection to unit rate more readily as they draw on prior knowledge of number lines.
These examples show the difference in proportional and non-proportional relationships with the same context. Note the equivalent ratios in the table in the proportional example, where the constant proportionality is the unit rate, which is 55 miles per hour. The ordered pairs create a straight line through all the points and include the origin. The non-proportional relationship example does not include the origin, as this vehicle must have had a 10-mile head start. The table shows the ratios that are not equivalent and the points do not connect to make a line. As stated, real-world examples or practical situations that model proportional relationships can typically be modeled in graphs limited to the first quadrant.
When discussing proportional relationships in context, it is important to note when the ordered pairs can be connected and when not. In the speed of the sloth example, time is continuous, so it is possible to consider how far the sloth moved in 2 1/2 minutes or 3 minutes 15 seconds, so students are allowed to connect the points into a line. Whereas in the example of candy apples, a person cannot purchase 2 1/2 candy apples or 3 1/4 candy apples. Therefore, students cannot connect the points in this graph.
Here is another example of a non-proportional relationship. The fact that this is non-proportional can be determined in a number of ways. First, the ratio of y to x for each ordered pair is not equivalent. Second, the points on the graph do not lie in a straight line. Finally, the line does not pass through the origin 0, 0.
This slide brings together many connections the teacher has helped the students make, namely, using the unit rate to find missing values in a ratio table, proportional relationships, constant of proportionality, and real-world context. Students use the mathematical process goal of problem solving throughout this standard. Please be sure to watch SOL 6.12 instructional and assessment videos to complement your learning. The video 6.12, 7.10, 8.16 linear graphing overview provides a connection for teachers to see the entire sequence in middle school.